Good morning everyone. Today we will start class 9 chemistry structure of atom. Atoms and molecules are the building block of matter. And there are different types of substances, elements, and these elements are made up of different types of atoms and molecules. For a long time it was thought that atom is indivisible. And as we have seen in the last chapter also, chapter number 3, John Dalton had told that matter cannot be divided. Atoms cannot be divided. He had told that atom is indivisible. But it is not true. We had seen later on it was proved that what he had told, his concept was wrong. An atom can be further divided, and atoms of different element consist of subatomic particles. We call them as electron, proton and neutron. When you will go to upper classes, class 11, 12, you will study in more detail that there are still more smaller particles than these electron, protons and neutrons, and we call them as electrino, protino, neutrino. Here we are to study in this structure of atom, we have to study about electron, proton and neutron. Suppose this is the structure of an atom. So here what we will see that this is the nucleus. In this nucleus we will see there are neutrons and protons, and around this nucleus there are orbits. These orbits, in these orbits electrons are there. Electrons are there. So what we see that an atom consists of electron, proton and neutron. In this also there are electrons. So an atom consists of electron, proton and neutron. Proton and neutron, they are found in the nucleus of an atom. Electrons, they revolve around the nucleus in the orbits. And now in this chapter we will study about each of them. So let us first see about the discovery of electron. How electron was discovered. Electron was discovered in 1897 by J.J. Thomson. This scientist, he discovered this electron in 1897 by performing an experiment or activity, we can say. Earlier he had done many activities, and after performing so many activities, in this final activity, this J.J. Thomson, or his full name we can say as Joseph John Thomson, he explained to us about the existence of electrons. What he had done, he had taken a discharge tube and he had connected them to a high voltage. In the discharge tube, he had taken certain gas, or we can say any gas, because the production of This electron does not depend on the type of the gas taken in the discharge tube. So he had taken a discharge tube, in that he had taken a gas. He had connected the discharge tube across high voltage and low pressure, and then what he observed? He observed that these electrons, sorry, not these electrons, he observed that cathode rays started coming out from the negative terminal towards the negative end. He observed so many rays coming out from the negative end. So when he observed so many rays coming out to the negative end, then he told that since these rays are coming from the negative end, or we can say from the cathode end, so these are cathode rays. And these cathode rays, they consist of negatively charged particles. We call them as electrons. Thus, in this way, he had discovered the electrons. Here I explained it in very short, because this discovery, how he discovered, that is not in our syllabus. In detail, you will study about them in upper class. What is here we have to study in our syllabus is that what are electrons. So electrons are negatively charged particles. They are the subatomic particles. They are negatively charged and they revolve around the nucleus in an atom. They are found in different shells, and all the elements, they have electron in them. Hydrogen has got only one electron, rest all elements have got more than one electron in them. These electrons, they keep on revolving around the nucleus of the atom in various shells, as you will see, shell number 1, 2, 3, like that, or we can name them as K, L, M and so on. These electrons have got certain characteristics. We will do about them one by one. For example, we will see about the charge of electron. The absolute charge of electron is minus 1.6 into 10 to the power minus 19 coulomb. This coulomb is the SI unit of charge. A relative charge of electron is minus 1. That means we are comparing, that's why we say relative. Next is mass. Mass of electron is 1.6 into 10 to the power minus 28 gram, 1.69. Charge is minus this 1.6. So mass of electron is 9 to 10 to the power minus 28 gram, or if you take in terms of kg, it will be 9 into 10 to the power minus 31 kg. So this was in terms of gram. Now we can see in terms of comparison to hydrogen. The mass of hydrogen is taken as 1 U, and then the mass of electron is taken as 1 by 1840 times the mass of hydrogen atom. Mass of electron is 1 by 1840 times the mass of hydrogen atom, and mass of hydrogen 1 by 1840U. So what we see that the mass of electron is 9 into 10 to the power minus 28 gram if we are talking in terms of gram. If we are talking in terms of kg, it will be minus 31 kg. Mass of electron will be in comparison to hydrogen, or if we take is in U, then the mass of electron is 1 by 1840U. So from this value, negative sign minus 28 or minus 31, you can understand what is the mass of electron. Mass of an electron is very less. It is almost negligible. That's why it is said that the mass of an atom is wholly concentrated in the nucleus, because of the mass of neutron and the mass of proton. Mass of electron does not play much role in the mass of the atom. And in an atom, number of electrons and protons are equal. So an atom as a whole is neutral. About this all we will study later part. Now we will do about the proton. Now we will see about the discovery of proton. Electron we have seen. So discovery of proton, it was done by Eugen Goldstein in 1909. Since Eugen Goldstein had seen that J.J. Thomson had told that in an atom there are electrons, and he had discovered the electron by taking any gas in discharge tube. In the similar way, in the same way, Eugen Goldstein, what he did, he took a discharge tube, but instead of taking any gas, he had taken hydrogen gas in the discharge tube, and he connected the discharge tube to a high voltage, and he maintained low pressure. And in that low pressure, after applying low pressure and connecting it to a high voltage, what did he observe? Eugen Goldstein observed that some rays were coming out from the anode end. And so he called these rays as anode rays. What did he call these rays? He called these rays as anode rays. And since these rays were coming out from the anode end, from the positive end, so he called that these particles, these rays consist of positively charged particles. And thus, in this way, the discovery of proton was done. The type of gas which we take in the discharge tube, on that the amount of proton, or we can say the anode rays emitted out, will depend. So this is because different type of particles, different type of elements, they have different amount of proton in them. Hydrogen has got one electron, one proton. Other elements, they have got more than one. And so which gas we will take in the discharge tube, on that it will depend the emission of the anode rays. Next we have about the characteristics of the protons. What we will see first about the charge of proton. is taken to be plus 1.6 into 10 to the power minus 19 coulomb. If we take the relative charge of proton, then we will write plus 1. When we talk about the mass of proton, then we will take this mass as 1.6 into 10 to the power minus 24 gram. If you take in terms of kg, it will be 1.6 into 10 to the power minus 27 kg. Now we will see the mass of proton in another way. That we can say that the mass of proton is 1840 times mass of an electron, and we have studied that the mass of electron is 1 by 1840 U. So this cancelled, so we say 1 U, and hence we can say that the relative mass of proton is 1 U. About the neutron we will study. The discovery of neutron was done by James Chadwick in 1932. See, it was thought that when these electrons are there, protons are there. For example, we take the case of carbon only. The carbon, what we are seeing, there are 6 electrons, 6 protons. And we have seen that the mass of electron is so less, and the mass of proton we have seen 6U. Suppose we take, or total we will add, how much it will be. But the atomic mass of carbon is how much? 12U. So it came into the mind of the scientist that how is it that there are 6 protons, 6 electrons, and mass is 12U. That means there must be something more which is responsible for the mass of 12U mass of that carbon. Similarly, they observed other elements also. In other elements also, they tried to understand that what is the reason, why is it that. So when they deeply studied, then this James Chadwick, he came to the conclusion that there is some more particles are there. A third type of particle is there in an atom, and that is responsible for the overall or the total mass of an atom. For example, in the case of carbon only, in carbon he told that it is 12U is the atomic mass, and there are 6 protons, so 6U, and then of neutron also 6U, so 6 plus 6, 12. Thus, in this way, the discovery of neutron was done. Next, we have about the properties or the characteristics of neutron. First, we will see about the charge of neutron. As we know that an atom as a whole is neutral, and there are as many electrons as many protons are there. So total overall charge is 0. That means if neutrons are there, then what is their charge? Because if it will have positive charge, then an atom should be positively charged. If it is having negative charge, then the atom should be as a whole negatively charged. But it is not like that. The atom as a whole is neutral. That means this particle neutron is only having no charge. So it was told to us that this neutron has got no charge. It is neutral in nature. Next we come to the mass of neutron. So the mass of neutron is said to be equal to the mass of proton. As we saw in the case of carbon, 6 we are taking of proton, then 6 we are taking of neutron also. That means the mass of neutron is equal to the mass of proton, we can say. Then mass of, this is relative mass, we can say that the mass of neutron in terms of gram is what we had taken of that of proton, 1.6 Newton to the power minus 24 gram or 1.6 Newton to the power minus 31, sorry not 31, 27 kg. And if we take the relative mass, then it will be 1 U. Just you say in terms of U, if we take the mass of neutron, then it will be equal to the mass of proton, that is 1 U. Yeah, then we will see the next part of the chapter another day.